So in the given problem, he is given two generators with two transformers and two transmission lines which are in parallel. So he is asking what is the fault current if a line to ground fault appears at bus P. So we know that if a fault appears in a power system, the fault current in case of a line to ground fault is equal to 3 times E by x1 plus x2 plus x0. So here if I consider E as 1 per unit, because he has already given all the values in per unit, so this has become 3 by x1 plus x2 plus x0. So you have to calculate x0, x1 and x2 for this network and then substitute here. But if you see here, he has not mentioned the transformer connection here. It was missed actually. Actually it is, this is a star connected with a ground system this side, and this side it is a delta connected system. Now first I will try to calculate x1, that is the positive sequence impedance of the, or positive sequence reactance of the network. So if you see here, this is a generator having some positive reactance, and transformer is having some positive reactance, and the transmission line is having some positive reactance, and this is a bus B, then the transformer, then the generator, and here are the voltages, generator voltages, positive sequence voltages. So this is given as 0.2, this is 0.05, this is 0.16, 0.16, 0.05, 0.2. This is G2 and this is G1. So how to calculate x1? So because the fault is here, so this point is connected to ground. So if you see here, this system and this system are parallel because the current is feeding from here and the current is feeding from here. So these two are connected in parallel. That means this reactance and this reactance are in parallel. So what is this reactance? This is 0.2 plus 0.05 plus 0.08. So this value is 0.33. Or if you want, you can put J, because it's all reactances, doesn't matter because he's asking only in magnitude. So here this is 0.2 plus 0.05. So this is 0.25. So x1 is equal to the parallel combination of these three, J.33 parallel combination of J.25. So if you simplify this, you will get 0.1422. So x2 is also the same value, 0.1422. We know that x1 equal to x2, just only these values will not be there. If I draw a positive sequence reactance diagram, I'll get the voltage in series with the positive sequence, but if I draw the negative sequence, I have to draw only the reactance. I should not draw this one. So the only difference is this EMF or the voltage. Okay, now x0. So to find out x0, it's very important to see how the generator and the transformers are connected, star or delta, ground connected or how. So if you see here, the generators are connected with a neutral reactance of xn, so that is 0.04. So we know that when we are drawing the single diagram, we have to represent 3 times xn. So this is 3 into 0.04, this is 0.12, and then generate reactance, zero sequence reactance, and here the transformer. So here I will show you how to draw the zero sequence current impedance for this transformer. If you see here, this is a star on both sides, it is grounded. So in this case it's only simply x0 will come, but in this case it is different because generally while we are drawing or while we are denoting the zero sequence, will be denoting like this with this series switches and parallel switches like this. So whenever you have a star connected with a ground, these switches will be closed. For example, if it is this side, so here this will be closed, and these are for delta connected. Since it is not a delta connected system, it will kept open. But if you see this side, it is a delta connected, so this will be closed and this will be kept open because this is not a star with grounded. So finally I can represent this whole value with like this. And here it is open. So this is how I will represent for this zero sequence reactance. And here it is normal directly. Now I am going to represent these two in the single line diagram. So here generator reactance this one, and here transformer reactance, zero sequence reactance. After transformer I am having transmission line, then transmission line I am having again transformer. Here transformer, how you have to represent? So in this end it will be like this, then after that it will be grounded, and after that here it is open, then after that generator reactance, and after that generator neutral reactance. So this is how the zero sequence reactance circuit or network. So this is generator reactance, zero sequence. How much this is given as? Generator reactance is given as zero sequence, it is given as 0.05. so this is 0.05. transformer is also given 0.05. transmission line it is given as 0.5, and this is 0.05, this is 0.05, and this is 0.12. the same thing, 3 times the actual neutral reactance. Now the fault appears here, the bus B, this is the bus B, so that means this is also grounded. Now you can see the parallel of this and this, but here this will not come into the picture because this is open circuit, so this will not come. The parallel combination of 0.05 and this reactance. How much is this reactance? This reactance is 0.05 into 2 plus 0.25. So this is equal to 0.35. Sorry, I think here this is also there, na? So this is plus 0.12. So this is plus 0.12. So this is 0.47. So this side this is 0.47 and this side is 0.05. So x naught is equal to 0.47 in parallel 0.05. So if you calculate this, you will get 0.4519, or you can say 452. Now the fault current is equal to 3 by x1 is 0.1422 plus 0.1422 plus 0.45. Sorry, this is 0.045. Sorry, this is 0.0452. So this is 0.0452, and if you simplify this, you will get 9.1019. So we'll see the options. So here option E is the correct answer.